Well, good evening, everyone. Great to see you all here. My name is Mike Brooks. I'm the Provost and Deputy Vice-Chancellor of Research here at the University of Adelaide. Can I start by acknowledging the Kaurna people, the original custodians of the Adelaide Plains and the land upon which the University of Adelaide's campuses at North Terrace, Waite and Roseworthy are built. Thank you all for coming along to tonight's Research Tuesday's event, Thought for Food. It's great to see we still have tremendous wit in the university. Food and wine production and processing is a major industry globally, nationally, and particularly for the state of South Australia. We export 80% of the nation's premium wine exports, and over half of the state's exports themselves are agricultural products in nature. In this field, there are great opportunities and great challenges, and I'm delighted to say that our researchers are working hard to help us retain a competitive edge in production quality, cost effectiveness, and taste. This is why food and wine research is a key focus for the university, and one of the reasons we established the Food Innovation Research theme last year. The theme provides an umbrella for more than 250 academic staff members across all of our faculties. And tonight we have 4 of our researchers here to talk about some of their latest discoveries and industry partnerships. Following a presentation from each speaker, they will engage in a panel discussion, and later you, the audience, will be invited to ask the group questions. So it's my great pleasure to introduce the director of the Food Innovation theme, Professor Andy Lowe. Andy's research background is in plant genomics, particularly the monitoring and management of genetic and biological resources. Andy's role as director sees him building relationships and working closely with industry and government partners across the food sector, identifying joint innovation and training opportunities. Please welcome Professor Andy Lowe.
And good evening. It's good to see so many people here tonight. I'd like to start out by really emphasising that food production and processing is going through its biggest change since the Industrial Revolution. We have a range of technologies that are being applied into this sector like never before. Genomics, robotics, and a range of consumer understanding are all colliding within this particular area. But the issues that are facing food production are some of the most serious on the planet. We have a hungrier world. We have a growing population, 9 billion estimated by 2050, and food demand is estimated to increase by 60 to 70% on today's levels. But we also have a wealthier world. We have the emergence of a new middle class that are increasing their demand for premium food and wine products. We have choosier customers that want to know where their food comes from, whether it was ethically produced, and also whether it was sustainably sourced. We have these transformative technologies that can help in some of these areas, but also represent issues in terms of consumer understanding. And we also have issues with a bumpier ride. We have tremendous changes in political systems, financial uncertainty, and also environmental and climatic change. We also know at the same time that too much of the wrong sort of food is bad for us. We have problems with keeping our health budget under control, and those non-communicable diseases proliferated by poor diet could be part of that solution. And finally, food production is one of the leading causes of some of the Earth's major environmental problems. For example, in Australia, 60% of land use is dedicated to food production, and 70% of freshwater use is dedicated to food production. So more than ever, we have these major drivers for sustainability within our food production and processing sectors. At the University of Adelaide, we have a tremendous wealth of expertise that exists across the university. As Mike said, there are some 250 academics involved in a range of research and teaching around food production, processing, and markets. Those research staff are across the 5 faculty, the sciences, engineering, the professions, the medical sciences, and also the arts. And I'm just going to take you through very briefly today some of the key areas that we've highlighted as potentially being real opportunities for helping to tackle some of the major challenges that we see that the sector of food production and processing is facing, and where the university has key expertise that can help develop the innovation that provides solutions to some of these challenges. The first area here is around functional foods and healthy grains. This is really the collision of engineering and medical science. Understanding and breeding improved nutritional sources of our staples so that we're not only getting the calorie intake, but we're also getting a balanced nutritional intake from those particular products that we consume. Issues around low gluten wheat or high gluten breeding, which can help solve issues around blindness, are certainly focuses of some of the work there. Second area is around livestock production and welfare. Certainly the production of the production of livestock here in Australia is a tremendously important issue. We have the Roseworthy campus, which is located to the northeast of the city, and it has a very long history of livestock research, but we're starting to see that research really incorporating a large number of innovations around technology to help with the production, the breeding of new varieties, and also understanding welfare issues around that livestock. The university has a very long and strong tradition in wine research, but we also, that research is tipping over to support a range of food science areas as well. The wine research expertise is located out at the Waite campus, and some 70% of all researchers and those involved in the wine sector within Australia have been trained here on the Waite campus. We have tremendous opportunities within the native food sector. We all know about bush tucker and putting a bit of kangaroo with a bit of native flavouring on the barbecue, but really we have some 35,000 plant species here in Australia, and none of the major crop products that are grown around the world come from Australia. And there's only one plant that's been domesticated from Australia, and that's the macadamia nut. So we potentially have a wealth of new crops that are on our doorstep here in Australia. I should introduce that Kate Delaporte will talk about the native food industry in her talk, and Trent will also talk about the wine research in his talk. Perhaps one of the most exciting areas is the inclusion of automation and robotics in the agriculture, horticulture, food and wine production areas. We're going to see increasing automation in these areas and increasingly use of technologies like machine learning to visualize, understand what's going on within systems and then help come up with a solution. This can help make Australian farmers much more productive and competitive in an increasingly competitive global market. Food waste has to be one of the major issues that is facing society at the moment. Some 40% of all food that is produced and processed here in Australia ends up as waste. It ends up in landfill. This causes environmental issues in terms of the greenhouse gases that is emitting. But just imagine the cost of that. On average, a household will waste $4,000 of food a year, and we should be able to do something about this. Novel techniques include converting farm waste into new cosmetics and nutraceutical products, and even biofuels. Increasingly, consumers wish to know where their food comes from. We have a range of biomarkers. These are chemical DNA-based markers that can be used to identify which food you're eating and where that food comes from, and even in some cases whether it's on the edge of safety or not to consume. And Mark Hutchinson will talk a bit more about those technologies in his presentation. Sustainability is also a key issue, particularly with discerning customers. We want to know whether the product has been produced sustainably or ethically. And this touches on issues of water use efficiency, it touches on energy efficiency, but also whether the soils are being properly managed, whether the carbon mitigation of the production and whether carbon neutrality can be achieved from the sources. And even using and harnessing ecosystem services, for example, pollination, and supporting those in the production of our food. Perhaps one of the biggest changes is around customers and markets. Australian farmers used to produce largely for a local market, that went to a national market and now is moving to a global market. That has benefits in terms of new markets that open up for the growers and producers and processors, but it also represents increased competition for cheaper products potentially coming in. We have premium green produce that's produced here in South Australia and over much of Australia. If we can't achieve a market advantage by demonstrating that produce, then we failed that food production industry. But we need to be able to understand those markets, and we need to be able to understand what the tipping points are for those markets to prefer Australian produce over other areas. It's a complex area that involves research in the social sciences and also in the professional sciences, including economics and law. University's role is really around training that workforce for the future. I've talked a bit about the wine industry and also the support from Wait. We're also embarking on understanding really exactly where the new industry of food production and processing is heading, what kind of new skills are demanded within that sector. If we have increasing automation, if we have increasing technology that's being brought to bear within food production and processing, then we also need to be able to understand those changes, and we need to be able to train the next generation of those involved in that production and processing landscape so they have the skills to be able to take Australia forward. Mike's talked about the incredibly proud food history that we have here in South Australia. But we also have this incredible history of research that's underpinning those innovations with food. Some 50% of all grain varieties that are grown in Australia were produced here in South Australia on the Wait campus. And 70% of all wine research that's undertaken within Australia is undertaken here in Adelaide on the Wait campus. So we have these absolute jewels in the crown of Australian production and processing research that occur here. University is committed to bringing these resources to understand the key problems facing this sector, to help drive the next wave of innovation that occurs around this sector. Across South Australia, we have key production areas for wheat, canola, aquaculture, barley, of course, viticulture, almonds, citrus, and a range of horticulture and livestock products as well. The university, through its research, is working with a range of industry and government groups around these particular sectors, understanding what the problems are that are facing these sectors, and then helping to develop the research and help develop the innovation that can help support and drive these sectors forward. So I finished my brief introduction. What I'd like to do now is we've got 3 presenters that will stand up, and they will talk about one element of some of the key focal areas and key innovations that we've been discussing. So I'd like to now introduce Professor Mark Hutchinson. Mark is Director of the Australian Research Centre of Excellence for Nanoscale Biophotonics, and he's a professor within the Adelaide Medical School. He has previously established the university's Neuroimmunopharmacological Research Laboratory and worked in the world-leading Centre for Neuroscience at the University of Colorado. Welcome, Mark.
Thank you very much, Andy. And thank you tonight for coming along to hear about how a medical scientist is now doing food research in a convergent science program to advance local South Australian, but also Australia's food industry, to make a benefit to translate both clean and green, but also hopefully in the future a happy and healthy food product. And my job tonight is to tell you about some of the new measurement technologies that we're developing here at the University of Adelaide within the Centre for Nanoscale Biophotonics, just in some labs literally through those doors into the Brags. The motivation that is driving our research program arises from a series of key questions that producers, processors and the consumers are asking about foodstuffs. Specifically to try and optimise process to know when to pick some fruit. Is this ripe? Will it taste good? Is this the right time? Is tomorrow the best time? That it's going to rain? Is this grape going to burst? But also into the future, I have a crop that's going to mature in 9 days. Do I order the truck to come then, or do I wait a 10th day? Do I schedule my casual workers to come onto the farm in 2 weeks' time, or do I need them next week? There's going to be some bad weather. Do I try and get my crop in before that bad weather, or am I going to hit my bottom line too hard? And then there are you and I, who are the consumers of this food, and we are always hearing from our friendly clinicians, eat happier, eat healthier, and do it in a smarter way. How are we supposed to make these decisions, and how are the farmers and processors supposed to make these decisions without new technologies and new approaches that provide them with this valuable information? Now, decision-enabling measurements are around you all the time. You have them on your phone when it beeps and your battery's running out, often an iPhone. You have your thermometer that is telling you how cold this winter is. As well as when you go to your clinician, they do the standard metrics of how your blood pressure and heart rate are. These are all enabled by fairly standard and in some cases very advanced measurement devices which provide information for the users to make a decision. However, in the food production industry, there is still a lot of science but a fair bit of art that goes along with the process. That is because we need to not consume the food to make that measurement. Now, often as a scientist, we love to taste or try what we are researching, and as a medical scientist now doing some food research, it's wonderful to be able to go and taste what you're testing. However, if we were to take that literally for everything that we were producing, we wouldn't end up with very much undisturbed on the supermarket shelves or in your pantries. We need these measurement devices, these decision-enabling measurement tools, to make these measurements in a non-destructive way. And this is where some of the work around medical biophotonics is changing the way we are doing measurements in the foods sector. Light has unique properties that allow us to engage it, to interact it with biology or with a foodstuff, to make a measurement in a non-destructive and relatively cheap way. Now, I'm just going to do a little experiment with you, and you can go along with me if you have your mobile device. Of course, it's turned off. But here, I am now performing biophotonics simply by making my finger glow. Right here, you have a technology which can give you your heart rate, and in some cases, if this is a slightly smarter light and a slightly smarter detector, it will give you your oxygen saturation. And all I am doing is asking the light to pass in close proximity with my biology to give me an answer to say, yes, I have red blood and that's good and I'm still alive and doing quite well. But if we do this in a slightly more scientific way, we can start using different colours of light, shaped in different ways, interacting with multiple biological or foodstuffs to give us a measurement at a detector. Now, the little experiment I just performed was that light interacting with my finger, and the detector in this case was my eye. But in the space that we identified as part of the Centre for Nanoscale Biophotonics, we extended our research program from just looking at human and veterinary biological targets into the food domain by inserting food and foodstuffs into that light path to start asking questions of what is this food? Is this good food? Is this bad food? Is this really good food and I should be increasing my asking price? Or is this food off? Or in fact, it's not what the carton says it is. Now, the other advantage we have here at the University of Adelaide is that we have extremely unique fibre drawing technologies, literally 20 metres that side of that wall here in the Brags. We're able to manufacture glass and non-glass products, but products that are able to shape and sculpt light from one point A to point B, which may not be connected in a straight line. It might be down a convoluted pipework in an old retrofitted ice cream manufacturing facility, or somewhere down in the vats of a winery in the Barossa. Being able to take the light to the place we want it to go, to make a measurement, and then bring it back out, means that we are actually able to take our science and our technology into these retrofitted scenarios where we are working with established processing facilities. So what are some examples of our science in the real world creating jobs here in South Australia in startup companies? Two examples that I can share with you are in the spectral change wine sensing technology and in our meat eating quality probe. So we have collaborations with our friendly Barossa winery, Yalumba, where we have our light sources and fibres literally dangling in wonderful white wine and that's fermenting in barrel and red wine that's maturing. We are measuring what's happening to this wonderful South Australian wine in real time for the first time without opening the barrel. Now, why would we want to do this? Why would the wineries want to make these advances in sensing technology? Well, in the Barossa, fantastic winemaking area. However, it's landlocked and we can't scale in the Barossa for large warehousing facilities because we need to have very expensive analytical labs right next to these winemaking facilities. Only a small fraction of the barrels are actually sampled for their wine maturation and fermentation process. And there would be significant advances in production efficiency and quality if the winemakers knew exactly what every single barrel was doing on their 1,000 barrel, for example, vintage. Our sensing technology has the capacity to scale to that size, so we have an Internet of Things like activity in the barrel giving us real-time measurements. And we have literally just put one of these into a 30,000 litre vat of red wine on the weekend to see how that wonderful red wine is maturing. Using a similar technology, we are now for the first time at line speed in abattoirs measuring the quality of meat. And this could be a large beef carcass as pictured here, or a lamb carcass. Now, you may be familiar with the MSA grading schedule, which is a world-renowned meat quality grading schedule. However, that is extremely subjective to who is standing beside that carcass and making the visual assessment of the quality of the meat, which provides your set point of how many dollars per kilogram you are paying for your steak. Our technology takes the guesswork out of that for the first time and the ability in the future to fully automate that assessment process. The other unique part to this science program has been for the physical sciences to be influenced by our agri and biological scientists. We are now learning more about light and how light can move through biology from biology. And a fantastic example of this is the discovery of photoreceptors in the roots of plants. And a unique discovery only just a couple of years ago was that light is actually trafficked down a plant into the roots to make a sensing measurement in the root of the plant. We didn't realise this happened, and we are now using some really interesting mathematical simulations of the stem of plants to understand if we can improve our glass manufacturing performance based on a plant structure. So why is this happening here, and why are we some of the only people in the world approaching the science this way? Well, this is a classic example of it can only happen at the University of Adelaide. We have 3 really unique campuses that are enabling this research. Here on the North Terrace campus, we have the physical scientists combined with the medical scientists. At Waite, we have the amazing plant and agri-science, and at Roseworthy, we have the animal production scientists. Together, and only together, can we actually know which measurements we have to make. We need to know how those are going to be made and which ones are the most valuable measurements that are needed by industry. And this is extremely unique to the Adelaide scenario. There are very few other places around the world where you can do such a breadth of research, and we're all happy to talk to each other. So thank you very much for the opportunity to share with you some of the journey we've been on, and I hope you have a lovely evening listening to some fantastic additional world-class speakers. Thank you.
Okay, thank you very much, Mark. Have you got the... there it is, good. So our next speaker is Dr. Kate Delaporte. Thank you. Kate is curator of the Waite Arboretum and Waite Conservation Reserve at the University of Adelaide's Waite campus. There's a lot of weight in that sentence. She has co-supervised significant research benchmarking data for best practice production of muncheries, a promising native berry, and in 2015 engaged in a PIRSA-supported research project into the potential of Manuka honey. So Kate is going to tell us all about Australian native plants and opportunities. Thank you.
Now we're on. Thank you. Hello, everybody. Now, I'm going to have to do the whole glasses up and down thing because I'm in that strange place of my life where half the time my eyes work and half the time they don't work. Bringing the bush to the kitchen. Oh, there we go. So, when Europeans first came to Australia, they could not fathom the richness and diversity of our flora and fauna, or the history and knowledge of the local people. The land was seen as some by hostile, unforgiving, harsh and barren, but they just didn't know where to look. In Western society, as Andy said, we consume only a few hundred plant products as staple foods, but there are estimated to be over 5,000 Australian plants that are used as foods, medicines and tools by the Australian Aboriginal people. It seems we're missing out a little. Knowledge on how to find, harvest and use these products has been gleaned over many millennia by the people who use them. This knowledge has grown with a deep and respectful understanding of our land, its environment, plants and animals. Over the last 200 years or so, various Australian food products have made their way into our kitchens, most notable being kangaroo meat and good old macadamia nuts. But we're a long way from truly utilising the wild bounty of Australia, until now. Recently, there has been a resurgence in interest in products derived from our native plants. Key to this resurgence is a recognition of the need for sustainable development of any industries, and what better way to do that than to work with plants that evolved here in Australia. The recognition of knowledge and the ownership of that knowledge is driving ethical engagement with traditional owners, and it's a very important part of this process. As a horticultural scientist, fascinated by plants and how they grow, I'm very excited by the research and innovation opportunities available in this field. There's so much to discover in the raw products and flavours, be it salty, sweet, sour or umami, and a little bit of bitterness. It's all there for us, for the taking. Wild foods tend to be more nutritious than domesticated forms, so the potential exists to find new and natural sources of key nutrients and vitamins. Plants used as medicines can be investigated for new bioactive compounds, that is, compounds that have antimicrobial, antifungal, antioxidant, and just about any other anti you can think of. Why? Because I keep turning the screen off as I press the button. The University of Adelaide is embracing these research and innovation opportunities. Researchers here have a large range of projects underway. I'm just going to share with you how we can approach the development of a traditional plant product. And when I talk about traditional, I'm talking about Australian traditional products from traditional owners. They're a little bit different from what you might think of as traditional. First, the product and the plant selection is based on Indigenous knowledge and use. We need to think about, where does this plant grow? What part of the plant is actually used? And how is it used? Was it cooked or treated in any way before we ate it? This is important because people mistakenly eat foods thinking that they are okay to eat, but they do need to actually be cooked or treated and they die. But do we even eat it, or is it something that should be used as a medicine or a tool? And is it actually even delicious? That's a big question. This knowledge can guide us towards other things that the product may have, such as perhaps the leaves were actually steeped in water and the mash was applied to a wound rather than eating it. We can look for antimicrobial activity within that plant. Perhaps the fruits were used and shared with many groups across Australia, therefore they have properties for long-term storage. We can look at the range of environments where those plants were grown and see if the fruit harvested from different locations actually tastes different and may have different nutritional benefits. We can use that information to find the most delicious, productive and healthiest fruit of the plant. Once we have a promising product to work on, we get to what I think is the most exciting and important bit. Actually, how do we grow these things? One of our most important current partnerships is a blend of all of those things I've just mentioned. In 2017, the University of Adelaide joined with the Arana Foundation. The partnership strives to create, in the first instance, a database to collate and preserve traditional and new knowledge about Australian plants and animal products. An essential part of this is the collaboration with traditional knowledge holders. From this database and the shared knowledge, university researchers are working alongside the Foundation to scientifically interpret the food preparation methods shared with Jacques Zonfrillo by the traditional owners. He's using those methods to change the way the food is from the raw product to an edible product, and we would like to understand how that happens. It's important to know not only what is happening when the food is prepared, but why it's happening and how is this impacting on the product itself. Is it still healthy after it's been cooked or fermented or steeped in ash water? Is it safer to eat? And does it taste better? And here comes to my exciting bit, which is how do these plants grow? How do they produce the leaves, the fruits, the roots and the seeds, the bits that we eat or actually use? Does the flavour change if we grow them in an area that's not the same as the one where they grew naturally? For example, when a plant is taken from a dry environment and grown in a wetter environment, often it grows bigger and better. The fruit is bigger, it's more juicy, but does this actually impact on the flavour of the fruit and its nutritional qualities? Do they taste the same? Do they have the same colour, the same uniqueness that drove us to purchase them in the first place? Bearing all that in mind, we're now fast forwarding a few years. How do we go from research and investigation to a new industry? In the beginning, we start with some very passionate and dedicated people who work together to start growing and harvesting and selling the new product. At an early stage, we should set some benchmarks so we know where we are. Now, I've always thought of benchmarking from a horticultural perspective, which is about how the plant grows, but apparently it's a business performance tool. Who'd have thought that? So it's all about performance. How do we think about horticultural data in relation to performance, and how can we actually benchmark that? But what are we talking about with horticultural data? It can be about the growing and production conditions of the plant. It can also be about the fruit or the product, the quality of that, and how that might vary depending on how you produce it. Such data can inform current practice, telling the grower where they sit in relation to others in the industry. It can also tell us where we need to improve. How can we produce this plant better? What further research and development is needed? We really want to be a sustainable and profitable industry. How can we tread softly on this land and not create more problems than we've already got? So where do we start and what do we measure against? We start with a good understanding of the life history of the plant, including flowering time and the pollination needs. Once we have an understanding of plant growth and production of the fruit, for example, we can look at fruit quality characteristics, which can be measured and compared, and requirements set for different quality parameters and market endpoints. Assessments include defining the taste or sweetness of the plant, the fruit, the juiciness, the texture, the crunch, the mouthfeel, the size, shape and colour. As I'm telling you this, I'm thinking about an apple. All of those things you might think when you bite into an apple, and how do they change depending on which variety you're eating or what time of the year you're eating the apple. Once we've assessed those things and created a line for a new variety, we can look further into the nutritional and bioactive compounds that we might find. So let's look at munchies as an example. Kunzia pomifera, also known as munchies, is a small fruit from a ground cover plant that grows predominantly in the coastal areas of South Australia. The fruit is like a miniature apple, crunchy, sweet and a bit juicy. It can be eaten fresh or frozen and used as a fruit added to cakes and scones. It can be made into fruit leathers or jam. It's been around for thousands of years, or more recently, about 30 years. I remember eating it as a child from wild plants at my friend's property at Beachport in the southeast. It was delicious and quite mysterious and a bit sneaky that you were actually eating fruit off a plant that was growing on the ground. As a cultivated crop, it's been around for a bit, with few producers producing plants in orchards across South Australia. One variety, Riverlea Bay, coming from Riverlea Bay in the southeast, has been presented as the industry standard. It's easy to grow, it has large fruit, which are easy to pick and process. Munchies are quite small, they are about the size of your fingernail. So if you imagine crawling along the ground, harvesting those fruit, you really want to have the biggest fruit that you can get to make it easier to harvest. But is Riverlea Bay the best fruit with the best flavour? Which leads me to the research that Andy was talking about. Dr. Chi Mai Do, myself and Dr. Carolyn Schultz worked on producing fruit quality benchmark data for Riverlea Bay as part of Chi's PhD studies. Chi analysed hundreds of fruit over 3 seasons and found a great degree of variation across all the quality parameters I discussed earlier. Some of these quality parameters seem to be impacted by cultivation practices, but others were based on the natural variation found within the fruit. After 3 years, she was able to present to the Australian munchies industry a set of fruit quality parameter data that they can compare their fruit against that data and see where they sit in the industry. Producers can also see where they can improve on practices against the known methods and how their plants, which they're different to Riverlea Bay, actually compare to Riverlea Bay. And if you're wondering, for those of you who haven't eaten munchies or haven't looked at them, they not only taste good, but they are good for you too. They have been found to have 10 times the amount of antioxidants than blueberries. So buy local, buy native. So in case you haven't worked it out, I'm really excited about the opportunities in the native food and botanical sectors. I feel very honoured to be working at the University of Adelaide alongside people like Andy Lowe to develop the native plant industry within South Australia. I love working with native plants and helping passionate people to grow new industries. I really enjoy the connection to country and learning the traditional knowledge from the Indigenous people. I'm learning so much about plants that I never thought I would. Lifelong learning is what we get at university, and I'm really happy that I can continue to do that. It's amazing that it's all new to us, but it's been around for so long and so well known by the people. We just need to ask them and work with them to share the knowledge. So much to discover. Thank you.
Okay, thank you very much, Kate. So our final speaker for tonight is Dr. Trent Johnson. Trent is a research fellow within the university's Wine and Food Sensory and Consumer Research Group, located at the Wake campus. Part of the group's research focus is on the complex interactions between consumers, context, and wine to better understand the drivers of wine purchasing, perception, and consumption behaviour. I certainly enjoy a glass of wine. Does that count? Welcome, Trent.
Thank you very much, Andy, and hi, everyone. I'm a member of Sue Bastian's Sensory and Consumer Science lab based at the Wake. And sensory science is an objective assessment of a product's look, feel, aroma, taste, flavour. And consumer science is basically trying to work out which of those sensory attributes drive the liking or disliking of a product. And the product that we happen to work with at the Waite, or in our lab, is mainly wine. So I'm here to give a bit of a perspective about wine. So we've heard from Andy the contribution that wine provides in the agricultural sector, billions of dollars to the economy and producing or creating thousands of jobs. And as researchers, as Andy has just said, we try to better understand that pretty complex relationship that you as a consumer has with that glass of wine that you've got in your hand. And we like to believe that we're using pretty state-of-the-art technology to try and better understand that. And in some cases, we've had to develop technologies ourselves to help us achieve that. And one of those is a rapid profiling of sensory attributes to better describe or better understand what is going on in that glass of wine that you're enjoying. So you've got a glass of wine in your hand. What are some of the things that might influence whether you're actually enjoying it or otherwise? So the first lot is pretty well about yourself. If you're a wine producer or a wine researcher, there's not much that we can do about most of those things. The next lot could be physiological, your actual makeup. And the last one there mentioned is thermal tasters. So it's now recognised that perhaps 30 to 40% of the population, if there's some hot or cold stimulus applied to their tongue, will perceive something like acid or bitter or sweet or umami or even a metallic perception. And you can actually try that at home. Go home, get an ice cube out of the freezer, put it on the tip of your tongue for 20 seconds or so and see whether you actually perceive one of those sensations. If that's the case, then you're likely to be a cold thermal taster, and that may influence your liking of a chilled glass of white wine, for example. Clearly, the wine style or the variety of wine is going to influence. If you are trying a great variety that you don't particularly like, or someone's poured you a glass of wine and you don't like Cabernet Sauvignon, then that's probably going to influence whether you like the glass or not. Okay, the consumption context will also play a role. So this is the environmental and the social context in which you're having that glass of wine. So it's the who you're with, the where you are, when you're doing it, and why you're doing it are all going to play a role in whether you're enjoying the glass of wine in your hand. So most people, when they're trying wine or having a glass of wine, they're doing it with friends across a variety of different settings. It could be at home or at a barbecue, could be at a restaurant, could be a formal setting, it could be informal, it could be a celebration, or it could be a combination of all of those. And what you're doing is likely to influence how you're enjoying the wine. Most people don't try wine in a fairly sterile laboratory, but that's where most wine consumer research up until now has been performed. So you've got to ask the question, how realistic are the results and how reliable are they? They've certainly treated us fairly well in the past, but questions have been raised, and I'll touch on how we might overcome that sterile lab environment a little bit later on. And the last bit that I'd like to mention is the amount of information that you're provided when you're having a glass of wine can influence whether you like the wine or not, which is a nice segue into the first example that I'd like to share with you, which is the amount of information provided can influence how you feel about the wine. So in this example, we recruited 126 regular white wine consumers who were available to taste wine over 2 separate tasting occasions. At each tasting, they tried 3 wines, a Riesling, a Sauvignon Blanc and a Chardonnay, and they were provided with 3 different levels of information about each of the wines. The first time they tried the wine, they were trying it blind, so they knew nothing about the wine. And the second and third time they tried the wine, they were provided either with some basic information about the wine or some elaborate information about the wine. So the basic information was they knew they were trying, for example, a Chardonnay, and they were provided with some fairly basic sensory descriptors about the wine that we'd generated in the laboratory. The elaborate information was that sensory information, but embellished with information that we've got off the winery website, and we were using far more emotive language to describe the wines. Right? So we were very interested to see how the different information levels would influence people's perception of the wine. And firstly, we asked them how much they enjoyed the wine, and across the 3 varieties, very, very similar pattern of response about their hedonic or their liking rating of the wines. So from the basic, or from the blind information level, so no information, through the basic, through the elaborate, for each wine variety, there was an increase in their liking of the wine, which was a very interesting result for us. We also asked them a series of other questions, and for example, we asked them how much they're willing to pay for that bottle of, or for that wine, and very, very similar pattern. As the information levels increased, the consumers were willing to pay more money for that bottle of wine, which has, I guess, some fairly interesting implications for the industry. You don't only get information about wine from the back label, but there's also person-to-person interface, if you like. So if you go to a cellar door, or if you're in a wine shop, or if you're in a restaurant talking to the sommelier, they can provide information about the wine. So it sort of highlights the training and education that should go into people who are having that face-to-face reaction with consumers. The more they can tell you about the wine, chances are you will like it, and there is a high correlation between your hedonic response and whether you're likely to repurchase the wine. So some interesting observations, we think, for the industry through that particular experiment or project that we ran. Another example, and going back to functional foods that's been mentioned previously, Ganoderma is a mushroom that's been used as traditional medicine in Asian cultures for thousands of years. It's also grown in Australia, and as we've heard, Australia has a clean, green reputation for producing agricultural products. There's an increased global trend about awareness of health issues in relation to food, and our group's interest with functional foods led us to this project. So we got various levels of this Ganoderma extract, and we added it to a Shiraz wine, both pre-fermentation and post-fermentation. Produced a number of wines, got a whole hump people, culturally diverse backgrounds to come in, have a look at the wines, provide feedback to us about the wines, and as a result of that, we shortlisted 6 wines that we were then going to take to a consumer tasting, which we held at the Central Market last year, Because what we wanted, once again, was a culturally diverse sample, and what better place to get that than the market here. So what we saw is that the most liked wines were the ones with the lower levels of Ganoderma extract included. The ones that were least liked had the higher levels, and the feedback that we got from the people who were trying the wines was that they were perceived to be too bitter. So what we're working on now is how can we overcome that perceived bitterness. We also asked the sample if they could answer some questions about whether they were willing to try this type of wine in various social settings. And what we saw was quite positive responses, both from people from an Asian background and also from an Australian background, that they were keen to try this wine product. So there appears to be potential market, not only for people from Asian background, but also Australian markets for this particular wine product. So, you know, we've got something to work on seriously there with this Ganoderma extract. So, where do we go from here? We've just started a project with the Riverland Wine Region to use virtual reality as a way of providing information to people who may not necessarily get to the Riverland as wine tourists. So we're talking to wine tourists, getting their information. We're going to use their input to provide the content that will go into that virtual reality, so people can actually have a look at the Riverland from the comfort of their living room. And the upshot, hopefully, is to increase visitation and wine purchase from that region. We're also looking at using virtual reality as a way of immersing people into various consumption contexts to try and overcome that sterile laboratory. Very quickly, we're going to use our rapid profiling techniques to have a look at wines from across the Barossa Valley to try and work out what makes Barossa Shiraz uniquely Barossan, with a lot of other things. We're looking at food and wine matching. We're taking a scientific basis to that rather than anecdotal, which has previously been, you know, white wine with fish type approach. We're also looking at it from a cross-cultural point of view. And lastly, we're looking at mouthfeel as a driver for liking of wine, usually overlooked. So we're looking at wine body, viscosity and astringency in wine, looking at how those three things impact both consumers and experts' perception and preference for a series of wines. And just lastly, I'd like to acknowledge these people from the lab whose work has contributed to today's speech. So thank you very much.
Thank you. Okay, thank you very much, Trent. So we heard a diverse range of speakers tonight, all doing their bit for food production and processing here in South Australia. I'm going to ask them some questions now, and you'll get your chance to ask some questions. So I'd like to ask our three speakers to come up and have a seat, and we'll just kick off with a few questions. So I'm pretty interested in provenancing, and as a consumer, I probably want to know where some of my food comes from and how it's produced. And some of that will affect my purchasing decisions. So Mark, how's your technology going to help me make those decisions in the future?
So each product, let's say wine for example, will have a unique molecular fingerprint from various regions. We are exploring whether we can see that fingerprint using our light-based sensing to be able to provide provenance check so that this wine that was made in the Barossa and then is sold in North America is in fact the same spectral fingerprint that will then allow a consumer to have confidence that what they're paying for as a premium product, because it has excellent descriptors on it, trained by University of Adelaide teachers, and grown in under the South Australian sun, is better than your average other wine.
And what kind of biomarkers are you looking for? And what does your technology detect?
Well, that's
or is that the secret?
That's the secret
Oh,
sauce,
okay.
Andy.
Yeah, okay.
Have we all signed a confidentiality agreement? No, so there are a range of different measures that can be made. The beauty about using light as a measurement tool is that you can go from a very top-level measurement of simple colour down to specific chemical species analysis, again in a non-destructive way. Depending on which particular measurement is needed, and critically the price point that the industry and the consumer are willing to pay for that measurement, really determines which one of our toolkit we will apply.
So depending on the product, your technology can just focus in on the key biomarker that's relevant to the particular question.
That's correct. And so many of the cases that we have translated directly from medical science and clinical science into the food production setting have taken both the top level phenotyping or fingerprinting approach, which is very quick, but gives us good information because we're using machine learning to distill information out, and that's probably integrating up to 1,000 different things in our piece of information we're gaining, or we're measuring one thing very, very, very well and determining the concentration of that chemical within a complex array of chemicals.
Great. Thank you, Mark. I might pass over to Trent now. So do customers really care where their wine comes from? I mean, we hear quite a lot about France protecting the Champagne varietal name or regional production name, and we're seeing increasingly that countries or regions are seeking to trademark particular production names. Do customers really care?
Yes and no, I think, is the answer to that. Some of the research that we've done shows that the region of origin for Australian wine is probably in the middle of maybe 20 different factors that may influence their wine purchasing decision. There are regions that have a higher recognition factor both in Australia and overseas, like the Barossa, McLaren Vale, a Hunter and Yarra Valley are probably better recognised than a lot of the other regions, and we've got somewhere in excess of 35 or 40 now recognised wine regions. Listening to what Mark was saying is going to be fascinating, to have that sort of biomarker, absolutely nailing the provenance of the wine. At the moment, all we have is geographical indications. So if it says the wine is produced from the Barossa Valley, 85% of the grapes need to come from the Barossa, and that's about it. Doesn't say anything about the quality of the wine, although you would expect there would be some level of quality, which is slightly different from some of the appellation control, for example, in France or in Italy, where you're guaranteeing that the wine is produced from that particular region, for example, Burgundy, but there's also layers of quality sort of inbuilt. We haven't quite got to that standard yet in Australia, but I think the more involved a consumer is with wine, the more likely that they are going to take account of the region in which the wine was produced when they are making their purchase decision. The less involved people are just going to go, oh, Shiraz, that'll do me. Yeah.
usually my decision is it's $20.
Correct.
So I saw some interesting statistics. There's the Barossa cluster that's developed to really promote wine from the Barossa region. But if you go back 10 years, the average price of a bottle of wine from the Barossa was lower than several other regions within South Australia. It was fourth or fifth highest, and you had Coonawarra and Clare, which was higher. Now, you know, the Barossa cluster would say it's due to the great marketing campaign and that, but and now, interestingly, Barossa is the highest price average bottle of wine that you can buy. So they've obviously done something good, but Barossa wine isn't any better than any of our other regions here, is it? It's a fickle audience that we're dealing with. Put you on the spot there, Trent.
Yeah, thanks. I guess we're fairly parochial because we're in Adelaide, and we're probably going to think that wine from South Australia, so the Barossa, McLaren Vale, Clare, Coonawarra, Langhorne Creek, even the Riverland, is better than stuff that comes from east or west.
That other stuff, yeah.
Yeah. The Barossa is a really interesting example. Probably the last 10 years, they've really got serious about trying to work out exactly what makes Barossa Barossa. They've been running a project for that period of time, trying to identify whether there are sub-regions within the Barossa which they can use as a marketing tool, and they've come to the conclusion that perhaps there are, but they're not 100% sure. And the terroir project that I briefly mentioned is adding to that work, so looking at climate, looking at soil physiology, soil chemistry, the clones that have been grown in relation to Shiraz, what combination of all of that is making Barossa uniquely Barossa. But whether Barossa Shiraz is the best Shiraz in the world, you're going to ask a Barossa grower, and the answer will be yes. If you ask someone from the Northern Rhone, they're going to say, of course not. Our terroir is the best in the world to produce Syrah. Yeah, consumers are very fickle, very parochial.
Yeah.
But as long as they enjoy what they've got in their glass, then that's important.
But we have to keep up and maintain an understanding what customer base is wanting, and that's critical.
Absolutely.
Thank you. Kate, so native foods.
Yes.
So you've got a choice of 5,000 potential products. The sandpit full of interesting species. How do you prioritise which ones to actually start working with that could be the next carrot or the next key crop that might come out of Australia? I didn't prepare you for that question.
That's a very big question, Andy. And over the last 12 months, we've been working on that very process, and it's come down to understanding the information about where the plant comes from, where it grows, and how well that would adapt to commercial systems. How does it taste? How can it be fitted into our lifestyles as Westerners? Is it a food substance that we would just look at and say, I can't eat that because it is something that does not fit into my general restricted palette of foods? We also need to look at deliciousness and ability to be harvested, processed, cooked, stored, all of those things. So it's not a simple case of, oh, I really like the look of that salt bush, so I'm going to take that and put it into commercial cultivation. It's not that simple. But with a good understanding of all the different parameters, we can actually start to make intelligent choices about what plants we might bring into it. And then there's the story behind the product itself. Where did it come from? And what's the history of its usage? If it's associated with something really significant for the traditional owners and they're prepared to share that with us, I would feel personally that a plant, piece of a fruit that had a great story behind it would encourage me to eat it more than something that didn't have that story behind it. And so it's a bit of marketing, it's a bit of understanding the triggers that people would like to buy a particular plant. So it's not a simple answer to a very complicated question.
And thank you. So it's not all about science, it's about stories as well, and we've seen that with the wine example, which was nicely demonstrated. I guess I'm obviously not from Australia originally, but I'm wondering why Australian native plants haven't kind of gone before. So why, out of the top 150 crop species from around the world, none of those come from Australia. Yet we have a wealth. So why haven't we been able to develop this native plants industry here in Australia previously?
Do you really want me to tell you?
I think it's an interesting question.
It's an interesting question, and it's a loaded question, and this is my opinion, and it may not sit well with people in the audience. We all came from other countries. We brought our other countries' food and culture with us to this land and ignored the culture that was here. That's why we don't eat Australian plant products. We have to open our minds and hearts to the culture that was here and look outside of our pantry cupboards to look for those new foods and products.
And as you demonstrated, there's a range of potential medical benefits from those. High antioxidants, high vitamin C content. Why aren't we eating those? That should be the question. I think that goes back. Yeah. Trent, I might come back to you just on markets. So, we consider markets for native species, but markets for wine. So, probably here in South Australia, we're very proud of our wine, and we will select out. I'm now very familiar with the different wine growing regions here in South Australia. I've tried quite a few varieties. But how do we get on with exporting our wine internationally? And do other cultures and other countries, do they have similar tasting profile preferences, or do you have to produce wine that's specific for different preferences of different exporting nations?
Okay. I guess most of you would be aware that China is emerging as potentially the largest wine market on the planet, and the Australian industry has had a major push to get recognised as a producer of premium quality wines in that market. So we were approached to have a look at developing a special occasion wine for the Chinese market. All right? And so in conjunction with, once again, the Riverland wine region, we undertook that project. And it started with a series of focus groups involving Chinese wine consumers who were living in Adelaide, asking them about the types of wine that they like to drink, and specifically what wine they would consume at this special occasion. I mentioned it's a special occasion, it's a wedding wine, right? So we're trying to develop a wedding wine for the Chinese market. So we got ideas from the focus groups that put us down the track of, okay, let's produce a series of wines that match some of the data that we got out of the focus groups, and that's where the Riverland came in. So we had about a dozen different wines. We profiled them. We came up with a sensory profile for each of these wines. We then had a tasting in Adelaide with Chinese consumers to find out which of those wines we were liked and disliked and the reasons why. So that gave us an idea of what we should then take to China. So we took 6 or 8 wines to China in 3 different metropolitan areas. We got Chinese consumers in on their home turf to try the wines, but we also had a really detailed questionnaire that we asked them to complete, and the types of things that we were looking at were bottle shapes, bottle colours, label preferences, whether it should be screw cap or cork closure, what was preferred. So we were looking at...
Come on, Trent, you're going to have to put me out of my misery. Tell me what the answer is. Go on.
I'm not going to tell you what the answer is because I think that might be a bit proprietary. But we did come up with a product. We came up with a wine. We came up with a bottle shape. We came up with a label, and we came up with a bottle colour that is now working through the Riverland to get into that market. And so the research that we've done, we're quite confident that that product should sell for what is quite a niche market, but a niche market that would exceed probably all of the Australian market combined.
But without giving away trade secrets again, basically the shape of that bottle of wine and the colour and the taste would be different to that which would typically sell well in Australia.
Yeah, absolutely. Yeah. I don't know if many of you have heard the story of Chinese wine consumers drinking Grange with lemonade or orange juice added. And those of us who are shy go, that's horrible, but if that's a way of getting wine into the Chinese market, then who cares how they want to try it? If that's...
Okay, we're being very honest tonight. That's good.
Yeah.
All right.
And I probably wouldn't drink our Grange that way. Not that we drink Grange that often.
No,
but,
that's right.
If that's... Yeah, so they certainly have a different taste. They enjoy different styles of wine. Yeah.
So Grange and Coke. Okay, no. Yep. Mark, so I get one more question and then we'll throw it open to the audience. So have your questions ready. So Mark, the technology that you're developing looks pretty cool. So you must have a range of investors knocking on your door, ready to take your invention and make lots of money out of you. What are the kind of barriers to getting that kind of technology into the marketplace so that it can be commercialized and then used by the sector?
So classically, what we like to do is create Rolls-Royce solutions for Datsun problems. So $1 million piece of laser tech sitting on the back of a ute makes me very nervous.
Makes me nervous too.
And so we haven't, in the past, been very good at boxing our technology up into deployable devices that are rugged enough to survive the operation by a semi-trained user. So in the past 3 years, we've undertaken a lot of work in engineering and really what's translation science to make technology that's simple enough, that's at the right price point or at least heading in the right direction for a price point, that is going to be translatable into the market. And that's not a simple process because we're dealing with very, very technical pieces of equipment which the scientists hold very dear, and making it dumber and simpler is just not in their vernacular, and yet it's what we need to do to get it out into the market. So that's meant that we've had to do a lot of additional work, but it has paid dividends because we have now got, in our startup companies from the centre, there are 12 people now employed across the state working in translating this technology out. And that's really exciting. So these are scientists that we would have otherwise had to let go because their contracts were up doing the science. Now they're doing the science in translation science out there with industry. That means that there is a lot of interest from industry, but they're only interested in the industry side because we started the engagement with them very, very, very early in the process, so that they were aware of the technology, they knew it was coming, and we hadn't, as one of the anecdotes I heard in meeting with industry, we hadn't created the magic green bean and then tried to convince industry that they needed to buy a magic green bean because it was the best magic green bean that ever existed when they didn't want a magic green bean.
You've seen that before.
I've seen that before.
Yeah, me too.
So we were able to co-invent and translate this technology together with them to then have them as the first customers ready to buy the technology. So we're really excited that hopefully by the end of the year we will have made, or the company, the Meat Eating Quality Probe company will have made their first sale by the end of the year, and that's after only being in existence for just over a year. And there's more work to be done in each of the domains, but having these really excited young entrepreneurs, again, many of them University of Adelaide graduates, now translating their science into the market, it's really exciting to see. And
Great.
I don't have to pay their salary anymore.
That's a win-win all round.
Win-win.
Thank you. Okay, we'll open it up to the floor. I think we have a roving mic at the back here. So if you have a question, please raise your hand clearly. We've got one here on my left, your right. And please address Kate, Trent, or Mark.
Hello.
Or me, yeah.
This question is directed towards Trent. The University of Adelaide, the School of Public Health, was involved with some research regarding alcohol and cancer. And one of the parts of the project was looking at the acceptability of a cancer warning label on bottles of wine. Does this present a threat to the wine industry in Australia, and what happens if other countries start doing the same thing?
What an interesting question.
You never know what you're going to get from an
No.
audience. Yeah.
Honestly, don't know. There at the moment, wine labels in Australia are regulated. The information that has to go on them. We haven't quite got to the stage of America where there are warnings about drinking whilst pregnant and that type of thing. And I haven't seen any research that would indicate whether or not that level of warning on American labels, for example, has changed the behaviour of wine drinkers in that market. If it was mandated in the American market, for example, that the cancer warning must be part of the wine label, then obviously any wines that we were exporting to that market would have to comply with their regulations. Whether it would be a threat in the Australian market if we had to go down that path, I honestly don't know. It would be an interesting area of research, I think.
Yeah, sounds like a good research project, doesn't it? So I'm always reminded by, in the UK there were cigarettes that were labelled death cigarettes, and then the low tar ones were slow death. And it seems to be, so you never really understand exactly what the consumer wants.
So Andy, there's actually a point there that, so one of my other hats is I do addiction research, and there's an opportunity in this space where we could create, by understanding the addiction and perhaps cancer-producing properties of alcohol, there are ways to modify the alcohol products so that they are non-addictive and perhaps non-cancer producing. And the only way we would be able to translate that is having a wine specialist and a medical scientist working side by side to allow that rapid translation. And that's something we're actively doing at the moment.
Great, thanks. I think we had another question. Yes, sir?
Yeah, I'll direct this generally to the panel because I don't want to pick on anyone. Maybe the person that's bravest. We've heard about potentially opening our hearts and minds to use native plants. Where are we now in respect to opening our perhaps hearts and minds for perhaps newer technologies that may really create some game changers in human nutrition? And particularly what I'm thinking about now is Australian science has taken an algal gene, put it into canola, and so now you have a terrestrial land-based crop that produces high levels of omega-3 fatty acids. Now, I wonder whether the panel share my enthusiasm for this type of technology being a potential game changer. And then the other part of the question is, if we do, then why are we currently underselling this, almost running this technology under the radar, almost apologising, and basically have permission for animal trials of this technology at the moment, and not opening the eyes of the world to this potential impact this kind of thing can have on human nutrition?
Okay, so we're getting all the good questions tonight. So, are we ready for GM? That's a critical question. I won't mind having to go with that one first. I think, look, the potential technology we have now to do gene editing is just so far away from the original technology that was used for genetic modification. We're now able to pinpoint specific base pairs and change those, and we understand what the genes are that are involved with that change, and we understand the character change that will make. It's not all the case for all genes and all plants, but the level of knowledge today is just so far away from what was originally on the platter 20 years ago, when there was this real backlash against genetic modification. So my personal opinion is we should be ready for this. We should be ready to embrace that. Now, for the omega-3 example, there are other ways to get omega-3 in those kind of products, and particularly for livestock, some of those can be around diet. So, we should be looking at other solutions, and some of those solutions can be relatively cheap. But the irony is that at Wait, we are developing technologies for gene editing that we wouldn't then be allowed to plant out those plants within the state here because of the moratorium on genetic modification. But they can be planted elsewhere in the world. So we're then not able to exploit and explore the benefits from that technology here within the state. I don't know if any of the panel have anything to add about that.
So I guess parallel to those developments in gene editing, which are very accessible and far more accessible than ever before, I think there are other advancements in a broader range of physical and biological sciences, for example, around the microbiome and soil microbiome around plants, to then modify, by modifying the microbes that are co-growing with the food products, actually contributing to what the food product is then able to create and the nutritional qualities in that food product. And then secondary to that is our own microbiome and how it helps us harvest the nutrients from those foodstuffs. So if we can understand that massive area of biology, we may be able to achieve more efficient food digestion from the same genetic stock without perhaps the need in the first instance to modify the genome.
That's right. So for me, I mean, it cuts to the very heart of kind of scientific discovery. If you can imagine the ever-expanding boundaries of human knowledge, but as the boundaries expand, that area of the boundary gets larger. And so, the microbiome is only really something we've become truly aware of in the last 2 to 5 years. And, you hear stories the microbiome can solve everything. I mean, that's, it's almost now, when you write grant applications to get funding for research, there are certain memes that occur through that. So, did I say that? I'm not allowed to. Sorry, DVCR, that would never occur. But 15 years ago, climate change. So, anything with climate change would probably get funded, not quite. But, microbiome is definitely one of those. But the issue is that we know now and understand that microbiome can affect a whole range of issues to do with diets, in terms of the nutritional processing, can affect our mood and can also affect our immunological state. We don't fully understand how that microbiome changes within our systems, how it changes by the diet we eat, and how it's associated with the plants that grow within the environmental microbiome. So it is one of the really interesting frontiers of science that we're going to see some really exciting research around. And it's directly relevant to food production and nutritional profile. There was a question down at the front. Okay, thank you, madam.
This one's for Dr. Kate. I was wondering if you've been doing any research. Sorry, I was wondering if you've been doing any research on ruby saltbush.
Which saltbush?
Ruby saltbush.
Ruby saltbush. Dr. Kate.
Is it working? It is working?
Go for it.
Ruby saltbush, it's a wonderful little plant. We're not actually doing any research on it right this minute, but it's on the list. So we currently have a list of 80 plants, products that we're looking to start research programs. There's only one bucket of money and 80 odd different plant products to look at. I often think about the almond industry is a really good example of how one plant have been investigated for thousands of years and become a really great food product. We've got 5,000 almonds to look at with very little money to actually start investing in them. So we have to be a little bit strategic about the plants that we start with. So ruby saltbush is a really good plant. The berries are quite tasty and it grows very easily. If you're interested in doing a research project with me, give me a call. We've got some ruby saltbush plants that are growing wild in the Way Arboretum. You can come and do some tasting and we'll do a little bit of citizen science. Depending on what level you're at in your education, you never know where the world might lead you.
Thank you. But in terms of prioritisation, there are 80 other species that are ahead of... Sorry, yes. Last question at the back, please.
You've been talking about winemaking and native plants separately, but is there much potential in using native plants in winemaking?
You can certainly use matter other than grapes in winemaking, but you can't call the resulting product wine. It has to be called a wine product or something. So the definition of wine is produced from grapes. The example that we provided earlier about the Ganoderma extract, if that actually gets to full-blown fruition, that would have to be marketed as a wine product. And that's, I guess that's an example of what you were talking about. So short answer is yes, but we can't call it wine.
Kate, people have been getting drunk on a whole range of products across the world for millennia, haven't they? Yes. So Vlad Juranek who's director of the Wine Research Centre out at Waite. So I believe he was doing work. They looked at cider gum in Tasmania and been able to isolate over 150 different strains of yeast that occur naturally in that particular region. Now, when you cut the cider gum, of course, the sap comes out. The yeast naturally land on the sap, high in sugar. And if you catch that in a bowl, then of course that will ferment overnight and produce quite a tasty alcoholic beverage. So I think there are certainly options for new alcohols, perhaps not wine, but new alcohols that can come from native plants. The other key aspect around some of the native plants is also fermentation in itself as a treatment. So some of the native plants are relatively astringent, quite bitter to taste. And there are a range of treatments that have been used over centuries by indigenous communities to actually make those plants and those products much more delicious. So some of those are preparations with ash water, seawater, but the fermentation of those products to help break down that astringency doesn't necessarily produce an alcohol product, but it does help produce a delicious tasting product. So I think there are definite benefits from looking at that fermentation together with native species. Anything more to add? All good. Thanks. Thank you.
Just a few words, if I may. So I think we need to be cognizant and enormously proud of the industry, the food and wine industry that we have in South Australia. I think we forget just what an amazing state we are in terms of the quality of food, the quantity of food and the quality and quantity of wine that we produce here. It's fantastic. And I think what we've heard tonight is there are remarkable opportunities to take that to another level and to boost production and quality into the future. Can I thank you, the audience, for turning out on a cold Adelaide evening, and it's wonderful to see you here. And this is a very discerning and intelligent audience. The questions are fantastic, I thought. And can I thank our panellists, Andy, Mark, Trent, Kate, for doing such a wonderful job. It's been terrific. I have a small gift for you. It is wine. I've written a small warning on the label, but it is to be used strictly for research purposes. But thank you, Kate. Thank you, Trent. Thank you very much.
Thanks, Mark.
And thank you, everyone, and good night.